Welcome to the session, guys. In our previous session, we have gone through it, the differences between standalone database, SD, and the types of databases in standalone process, and also RAC databases. In RAC databases, how many types of database configurations we used to do, like one node RAC and normal RAC setup, two or more node RACs. And also we saw that cluster and clusterware differences. Okay, group of nodes club together act as a single machine, that we call it as a cluster, and the clusterware is nothing but the software to manage the cluster itself. Okay, it's like technical terms, guys, but in vanilla flavor, or you can say layman language, cluster or clusterware, all together we can say group of nodes act as a single node, and it is going to access a single database. This functionality all together act as a single machine functionality. We call it as a cluster. Who will maintain to act all these nodes in a single? That's a clusterware software. Oracle has designed that software as a clusterware. Okay, that is the in a layman language we can talk about this. And also we have gone through that grid infrastructure. From 11G release to onwards, we have this introduction by the mean Oracle has been introduced grid infrastructure. Grid infrastructure is nothing but the combination of our cluster binaries or clusterware software, clusterware plus ASM into single binaries. You know, before 11G, we need to download this clusterware software separately, ASM software separately. It is going to including with your database software also, DB database software. But from 11G release to onwards, or 11G release to onwards, they have introduced this grid infrastructure. Grid infrastructure is nothing but the clusterware software with ASM software. So even somebody will say grid home or cluster home or ASM home or clusterware home, everything is same. Okay, everything is same. Why? Because we are using grid infrastructure from 11G release to new future. So everything is same. When we are going to configure the cluster means our grid, our ASM, everything in a one home. Okay, this path, if you can say this path, it's having cluster plus ASM. In this path, we are going to download the grid infrastructure software and we are going to unzip it. There we are going to configure. No need, don't confuse anything. If somebody will ask you ASM or somebody will ask you clusterware, everything is same. And then Oracle Home, right? Even we have installed the Oracle Home database where your database software has been downloaded and configured. Okay, database software has been downloaded and configured. This is called a database home or Oracle Home. Our database instance, where our database instance is going to located, it is going to identify this home. Database instance is going to identify this location. Okay, it's this home is having all the binaries, libraries, and also tools, SQL plus DBCA, all tools will be located into your Oracle Home location. Okay, now today we are going to see background processes and daemons in RAC. Background processes are, as we discussed yesterday, for okay, first we can go with this. If you can see in our standalone database, we are having one instance to access single database. Okay, this is our DB. This is an instance. Instance is nothing but combination of or group of your SGA plus background processes. Here we are having memory and background process. This is the memory, SGA, and background processes. Why these two? We need to access the database and maintain the database. This instance is required. Without this instance, we cannot able to access or manage this database. Similar way, in RAC, we are having two nodes. This is node 1 and this is node 2. These two nodes together accessing the database. Okay, this database, these two instances are accessing this database, and these two instances act as a single machine. That mean for us to see these two are the two different machines, but internally these two works together as a single machine. How come that is possible? By using your grid infrastructure software. Okay, grid infrastructure software. So each instance it's having own SGA. This is also its own SGA, and this is also its own SGA. SGA means memory. and also it's having own set of background processes. This node is having its background processes, and this node also it's having the background processes. Background processes we know, right? SMON, PMON, checkpointer, CKPT, DB writer, log writer. These five are the mandatory background processes. Apart from these mandatory background processes, we are having extra background processes also in Oracle. Okay. Apart from this, in a RAC instances, we are going to have these two. From these two setups are different. In single node databases, we don't have these global processes or Oracle cluster way related things. 1 second, guys. Give me 1 minute. Okay, guys. So in RAC, only these global processes and cluster where services are extra. Those processes running on all the instances. Here in our case, we are having node 1 and node 2. In case we are maintaining 3 node rack, the same thing will be there, and these 3 nodes together act as a single system. And these 3 nodes are trying to access the single database, which is there. If we are taking up the DB, this database in shared location, these 3 instances will connect to this instance, and this will access it. Okay, now we can see what are all these global processes. Okay, in other term, we call it as a background process in RAC. Other term, we call it as a background processes in RAC, extra background processes. These background process, we call it as even normal background processes, which we discussed the 5 PMON, SMON, DB writer, log writer thing, checkpointer. So these things we can see now in our session. Okay, what is LMON will do, and LMD and LMS, LCK, diag. All these are related to commonly L, right? L means lock monitor, lock manager service, and lock monitor daemon, a lock manager daemon, and lock control service or daemon, and diagnostic thing. I'll write it somewhere, and then I'll show you those things. What exactly this each and every background processes is. We are having some other global resource or global processes that are there. These 5 are the mandatory are important global processes in RAC. If somebody will ask you in interviews, you can say what are all the background process or global processes in RAC database. Apart from normal background process, these will be there. We have some extra background process. Those are, you can call it all these 5. And also these components, we call it as a daemons. What are all the daemons in RAC? Somebody will ask you. You can say CRSD, Cluster Ready Service Daemon, Event Manager Daemon, Oracle Cluster Synchronization Service Daemon, Oracle Process Daemon, and we have some other daemons also. But these are all the important thing which priority, like we need to what exactly these daemons will do, so that we can learn other things as well. Okay, these are all the high level daemons. If you want to answer it, you can answer this. It's sufficient. Okay, let me explain the daemons first, and then we can go ahead. And so important daemons, as I said, CRSD, OCSSD, EVMD, Oracle Process Daemon. So O means Oracle, PROC means process, and daemon. Event Manager, EV means Event Manager Daemon. Oracle Cluster Synchronization Service Daemon. Cluster Ready Service. Okay, CLUST, Cluster Ready Service Daemon. And this is Oracle Cluster Synchronization Service Daemon. Event Manager or Monitor Daemon. Oracle Process Daemon, or some other thing you can say. We have one other one, high availability also. High availability, it is important thing. OHSD, high availability. Oracle High Availability Service Daemon. Oracle High. This is basically writing from your root level things. Okay, high availability, high AVI, service demand, and is etc. Okay, I'll type etc. We are having so many demons, but out of all the demons, as we saw here, RACSINFOTECH monitor, that's okay. These are the main demons which are there in our cluster. We can go through these things. What exactly this process monitor, we can see first. Oracle process monitor daemon. Process monitor daemon. Okay, process monitor process monitor daemon. It will monitor what are all the IOs, input and outputs coming to your database. It is going to manage it, and also it will handles, and or else this process we can use it any hanger, like if any one of that process is hanged, if any one of that server level processes are hanged, or to monitor specific timer or cluster integrity to connect in between, those things will monitor by this Oracle process monitor daemon. Okay, it is also locked into your memory and runs as a real-time process. Memory lock, and also it runs as a real-time processes. Real-time processes. Simply, you can say it will monitor entire the cluster level services, and specifically real-time processes which are running on the cluster, which process is running as of now. Everything will monitor on this by using this process. Mostly on its logs. Logs means simple. I can say I have two node rack. Okay, one user has been connected from here to this node, node 1 and node 2, and both are trying to access a single database, right? This will access this database, and this one is also accessing. All our data files are stored in commonly in shared drive. So client process or user process is trying to connect this node. From here it is trying to access one data block. The same data block another user is trying to connect. At that time the connection is going to node 2. From here this user is trying to access the same kind of block from the database. What will happen? This block, once it is trying to read it into one node memory, it will be locked. It will be locked here. So another user trying to read the data, he can read, but whatever the information is there in data block, old information only. Suppose this user is trying to read it and is doing update. Okay, whatever the here the block is having the data employee salary 100 rupees. Okay, 100 rupees of employee salary. But what this user is doing, this is going to update the salary to 500 rupees. Okay, 500 rupees. This updated value is locked here, and the old value will be there here only. If these guys want to read the data, he can read this data only, but he want to read the updated data until unless this lock is released, or until unless this user has been initiated the commit. This information this user is not able to read it, he cannot read it. That is one thing, or one scenario. And another scenario, if you can take, while he's trying to update the information, okay, from 100 to 500, this instance got down, it has been shut it down. What will happen? This update statement, this will, the data block which is there, those blocks is going to copied or read these blocks to on this instance memory. The block will be transferred from this node to this node. This we call it as inter-node connection, and also you can say cache fusion also. If any one of the node is failed, the data is trying to, the blocks is trying to copy from this instance memory to this instance memory. That activity we call it as a cache fusion. Who will do that internally? That is going to do it your private IPs and virtual IPs using that. And we have some other processes or resources in a cluster level. Those GCS, Global Cache Service, I'll talk about in a few seconds. This will taking care of this block transfer from this memory to this memory. Okay, these locking system, as I said, if some user is trying to access some block, the block is going to lock it. These locks also it is going to monitor it by using this daemon. Okay, only just monitoring the scenarios, it won't take much activities on the server side, but these three, and this one is a very, very important daemons, but we can go through these three now. This one I'll tell you as part of another scenario where you are going to start your cluster services. We can go ahead with this one. Okay, now we can go with this daemon. What exactly this CRSD, cluster ready service daemon, will do? It will manage all the cluster resources. If you want to start the cluster services, if you want to stop the cluster services, who will taking care of those startup and shutdown or managing the cluster resources? And if any one of that resource, any one of that service is down, this daemon will take care of that responsibility, and it will start those services on the cluster. How this will take care of all the cluster resources start and stop? Why? Because we are using two instances. Here we have instance 1 and instance 2. So each instance it's having CRSD. This will monitor whatever the services are running on this node by reading the OCR file, Oracle cluster registry, OCR file. This OCR file will store all the cluster resource information. What are all the services I have? What are all the listeners I have? What are all the cluster services? Everything will recorded into your OCR file. That's where its OCR file is very, very important. If the file is missed, this cluster ready service daemon cannot able to read the resources which are there into your OCR file. That's where the cluster resource or ready service daemon will maintain your cluster or maintain your resources to start and stop. If any one of the service is down or any one of this node is down due to some other network issues or any other things, this CRSD will try to start those services. Okay, internally it will try to start those services. So this failure, we call it as a failover. Like whatever at the time of failover, we have this memory blocks, right? This will initiated some other this processes, GES and GCS processes. These are the global cache and global NQ services will be there. Those are stored into your memory level, and these two processes will taken care of the node or data transfer from one node to another node, and logs, whatever the logs they are happening, these logs releasing activities, those will taken care by these two processes. Okay, or these two services. Leave it. As of now, we need to learn about CRS, cluster ready service daemon. It will maintain all the resources in your cluster, and then if any failures happens for the application resource, the failover situation, the application is trying to access the database instance, this CRS will taking care. If instance is failed, it will redirect that client application connection or client connection to this. So these services will take care of that. And one more thing, whatever the cluster ready service is, once you have initiated the startup, this cluster ready service daemon will monitor whether all the services has been started or not. Once all the services have started, then only this CRSD process will start. Until unless all the service has been started, it won't start. That's where the CRSD important. You have to look first CRSD is up and running or not. Daemon. How we need to check? I will show you d.bin is one view or one command. We can check the cluster services or daemon status. I'll show you that. That is the important, guys. And OCSSD, Oracle Cluster Synchronization Service. This process will take care of your node membership. So if you are having two nodes, these two nodes are pinging each other or not. This process is continuously monitored to synchronizing these nodes or services. Okay, if any one of that node is failed, who will inform? This CSSD will connect with CRSD, and internally it will try to start it up the services and other things. So OCSSD, Oracle Cluster Synchronization Service, will take care of your node membership and the group of services and basic locking mechanism. This locking mechanism also it is going to maintain OCSSD. So if somebody will ask you what is the use of this OCSSD daemon, OCSSD daemon will take care of your node communications, and if anything happen, it will restart the node restart options also. This process we managed in root level. Okay, this we can say root level CRSD. This will work in our user session level. It could be a grid or it could be a Oracle, but this daemon will start and manage the root level services. This daemon will take care of your instance level or user level sessions, whether it is a grid user level or Oracle user level. services it is going to start. If this daemon is not running means your server or a cluster node is going to shut it down. The node restart is required for this. Even the CRSD is not running means our node is not running. Node restart, we need to restart the node again manually. Another one is event manager daemon. Event manager daemon will check the child processes event loggers and generating any events like how my all the cluster resource status, it's up and down. If any one of the resource is down, immediately it is going to communicate with the customers and applications saying that, hey, one of the resources is down. Please monitor that. So this will keep on monitor all the services which are running on the cluster services. If any one of the cluster services is down, this event manager will send a notification to the application users or the clients which are connected to this. So that is the importance of this event manager daemon. Let me okay. I'll take care of this. 1 second. Cool. Then take off this. Next one, we can go with global processes. Okay, global processes, LMON and LMD, LMS, these global processes. These are another way we call it as a background processes in a RAC service. Each one is having its own priority. Each one is a background processor, global or background process in RAC. You can say we have LMSN. This we call it as log manager server. This will maintain your global cache services. Okay. Global cache services. Another one is LMMon, log monitor process. Monitor. This will take care of your global NQ services. Global NQ services. ENIQUE. No problem. NQ services. First, we can go with this thing. What is this LMS will take care? See, if you can say something about GCS, Global Cache Services. If any node failures or the data which is there in our node 1 to data blocks only. By using this interconnect, the data blocks is transferred from one node, this node is failed, and to another node into memory SGA location. This block is moving from here to here. This GCS will take care of this activity. Okay, this activity we call it as cache fusion activity. Okay, most of the time when the user is trying to access, or if this user is trying to select some data from the database, while he's trying to access this data from this database, in between the instance is down, how the user is going to get that information in a RAC node? Immediately whatever the information he has been gathered, that will be in our memory level, right? Initially server process will get the information and put it into your memory. Whatever the information it is gathered, the same information is transferred from here to here, and this instant is going to pick the remaining information and it is going to give it back to that user process. So that is there. Who will take care of this? This GCS process will take, global cache service. Who will help backgroundly for this global cache service? This LMSN is the background process. This will help to do these activities in the background. Okay, this one to manage the log manager services which are requested by the GCS. Log manager is nothing but when this is trying to access the same information is also trying to access another instance. Until unless it is going to fix or fetch that information, this should be wait sometime. Okay, that is also we can talk about another way. Wait events will generated if your memory is very less. Okay, at that time also we will get wait events. It's a different kind of wait events. Wait events are so many types. It could be a CPU wait, it could be a memory wait, it could be IO wait, or it could be read wait, physical rates, logical rates. All these are related to different wait events. Okay, event will happen. Event is nothing but a situation where it is going to wait. Like if it is a wait event or it is going to a read or IO related thing, that is a that activity we call it as a events. Okay. So by this LMS lock manager will help when the instance failover or failed. These cache fusion services, like as and when the node is failed, the data it is going to copy from one node to another node, the block is transferred from one node to another node. This LMS process will help and internally to GCS. And this LMS process, we call it as another name is GCS process, Global Cache Service Process. And we have out of 5 global or background processes, only one which is it's a main service. It is going to support your global cache services. Global cache is nothing but the cache fusion services. Cache fusion services. It will gives your consistency blocks. Consistency blocks. Consistency. It will maintain the consistency in the instance level. Data should be consistent. If this instance is also not running, this is also not running, what will happen? The user is getting that error, no data found or instance is not available error. No data, it is not the no data, it is like instance not available error. So in RAC environment, it's a high availability architecture. So users cannot get the instance is not available, such kind of issues. Every time if somebody is trying to enter the data, create the data, insert the data, update the data should be accessed by all the instances which are there parallelly. Even though the user is connected to one node and is trying to insert the data which is there into your shared drive, that should be accessed by other users. In between is user is inserting or updating some data or information. If the instance is crashed, we need to maintain consistency of this data. This whatever the data it is there, that should be transferred to here. Remaining data also it should insert by using another instance memory to your database. Otherwise, we will not get the consistency data. That kind of activity is performed by this global cache service in memory level. For this global cache service, LMSN is the lock manager service process. It will help to that to achieve the consistency of the data. Okay, and also to achieve if any deadlocks happens, okay, it will happen consistency data. It will help. It will handle the deadlocks. Like is this user is not inserted something and is not going to commit anything, he's leave it as it is. He has leave it, the block is as it is. Okay, and some other user is trying to access the same time and both are trying to insert something. That object has been blocked by 2 resources trying to access in the same time. The object has been locked. That is called deadlock. Generally in our database, deadlocks will clear automatically. Why? Because this kind of processes, this LMS will handle the deadlocks. Okay, even though if it is not handled, we need to interrupt manually and we need to identify the deadlocks. We need to clear it manually. Most of the times, okay, 99% LMS will take care of these deadlocks. If anything's happened, we no need to mention more. I mean, if somebody will ask, I have some deadlocks in my database, how we are going to achieve? Generally, you can say we have to wait for some time. I mean, for each and every operation or transactions in the database, there should be wait events. But all the wait events, do we need to interrupt? Do we need to involve and then to try to fix up? No. Until unless it is raising issue or somebody has been raised, or when we are going to involve, generally the wait event should not continuously there. Suppose my select query is there, it should complete within a minute. I should wait for 2 to 3 minutes, that is fine. If I'm waiting more than 10 minutes, that is an issue. At that time, if any deadlock is there specific to that queries, we need to clear those deadlocks. Generally, for each and every query, there could be a wait event, there could be a deadlocks, and there could be a logs. Those logs will taken care by these processes. Automatically, those logs will be released until after this process has been completed. So no need to bother for each and every 8 events, and no need to bother about each and every deadlock until unless it is not completed within a time. Then we need to pitch in and then we can troubleshoot it. Okay, by using this will improve the performance also. How it is going to improve the performance? If it is maintaining the consistency, if it is going to clearing the deadlocks, what will happen if there is no deadlock? The number of users is trying to access the data very fastly. If the deadlock is there, users will not able to access the data. Why? Because multiple users are trying to access the data and the deadlock has been happened. There will be ideal. Nothing will be done on that database level. So we need to clear the deadlocks. Why? Because this LMS is going to clear those deadlocks and it is going to improve the performance. So these are all the tasks which are performed by your LMS background process or global process. Another one is LMON. This is a lock monitor background process. This is the type of global NQ service. Okay, it maintains the whatever we said, this global cache services internally. This lock monitor will maintain the as I said, this one is the consistency. It is going to provide the consistency of the data. For to make this background process consistency, even this lock monitor will help this consistency process. While it is going to maintain the consistency, this lock monitor process will help this GCS process to maintain this consistency using this process. So internally, all the global process works together internally, even though they have a specific functionality which is performed by individually. To achieve that individual performance, internally one-to-one, the global process will help each other. That is one thing. And also its main purpose of this lock monitor, if somebody will ask you what is the main purpose of this lock monitor, you can say node consistency. Node consistency means if you are trying to add one more node, I have 2-node rack now, 1 node and 2 node. This is accessing shared database. If I want to add one more node, 3rd node, to access this database, this LMON will take care of this consistency of this node, 3rd node consistency. But LMS will take care of internal in between these 2 node consistency as of now. But once the 3rd node is coming to the picture and the data should be accessed, the data which is shared in shared location, this should be accessed through this instance also. So node addition or deletion, if I want to remove this node and we need to maintain only one node, after I have added the 3rd node, if I want to delete the 2nd node, and the data consistency should be maintained. Who will maintain? Lock monitor will maintain that. So reconfiguration of the clusters and lock reconfigurations, all the reconfiguration related, lock reconfiguration, cluster reconfiguration, these scenarios, lock monitor will help them. Okay, to monitor those services. Okay, some lock has been, some node has been added, some node has been deleted. Who will identify those things? Lock monitor will deal such kind of information. All those node configurations, lock reconfigurations or cluster reconfiguration, all these informations maintains in a log format, logs. It will create all the log files, and those logs we need to monitor for that while we are adding the node or deleting the node. This will help for that way. Another one is LMD is one other background process or global process. Lock manager. Daemon you can say, or process also you can say. It's a daemon come global process. This is also support GES. As I said, 3 out of 5 global processes, we 3 are going to support LCK. Okay, this is especially for your cross instance resource manager perspective, it is going to useful. Okay, log process. This is also one type of GES, global NQ services. I'll tell you about this GCS and GES. Give me a second, I'll explain it here. in our database, each and every instance in a rack system, each and every instance we are having memory. Okay, this instance its own memory, this is also its own memory. This memory level global resource service will be there, or global resource directory or global resource service. This is the main or parent service which is handle all the resources, memory related information on the grid or cluster level, but it is stored in your database instance level, okay, or cluster instance level. This portion, how this global resource is maintained by using in the form of GCS and GES, global cache services and global NQ services. This will mainly help for lock of the resource and also to maintain the cache fusion, the data transfer between these two nodes, interconnects will help this GCS. Global NQ services, if any one node is evicted, or if any one of the node is going to add it, or removal of the nodes, at that time this GES process will help on that process. So these two process together we call it as global resource services. Those are placed into your individual memories on the nodes, like where our background processes are there in normal database system. Here we are having, where we are having under instance only, right? Instance is holds SGA plus background processes. Same way here also we have SGA plus background processes, and also we have extra in the same memory. These global processes are there. These global processes are maintained by these GRS services. This GRS service is divided into two types, GCS and GES. That's it. It's all about it's a lock. Okay, make the lock, release the lock. If any deadlocks happen, release the deadlocks, and maintain the global service processes or cluster services process by using these all five background processes are global processes in a rack environment. That is the high level information about your GCS and GES related things. Okay, let me explain this. Where? Go ahead. Okay, LMS we have already saw this, and LMON we saw what exactly the LMON will take care of these things. Okay, if any node is going to evicted, or if your node is going to add it, reconfiguration of your cluster, reconfiguration of the logs, those will monitor by this LMON process. LMD will handle the mostly, especially it is going to handle the deadlock kind of scenarios. Okay, if any deadlocks are occurred, who is going to detect the deadlocks? DAD. Deadlocks will detected by this LMD process, and it is going to hand over this one to handle the deadlocks, to release the deadlocks with the LMS background process all together to work. But to identify the deadlocks, so hey, in my instance some deadlocks is there, who will identify? This LMD will handle that, and this is going to maintain your cluster resources also with the help of CRS. This will help to cluster resources. If any one of the resources moving from one node to another node, data transfer or data block transfer, not the data block transfer, this will help. And LMD will identify the deadlocks, and it will help to GCS process, global cache services, to handle the deadlocks internally, even though it is performing identifying the deadlocks, but who will clear those? This by using this background process. Why? Because it's maintaining your global cache services. And lock processes, LCK is going to maintain the instance level resource request. Okay, if any one of that resource is trying to access the same resource, if any one of that request is trying to access, as I said, the same thing, to release the lock, the block is there, it is not yet committed, ideal time is 10 minutes, or it's waited for not the 10 minutes, it's like a minutes only, few minutes it will wait, and then it is going to clear up this thing and available this resource on another instance. If the same user, some other user is trying to access this information, who will take care of this locking, unlock this information, or block unlocking sessions in global level. This lock manager daemon will, this lock process will take care of this. It will manage the instance resource requests, and cross-instance call operations for shared resources. If any invalids happens, block level invalids, it will clear the invalids and validate the elements during the recovery. If you can say, if any invalid of the lock, this lock is not releasing, but why? Because it's by default lock should be released. If it is not happen, then it is waiting for some time, it is went to inactive state. At that time, this selected information we should not have in our shared drive. This resource from this instance, user is trying to access. Okay, user is trying, our client is trying to access this block. This block information is not there. Why? Because it's went into inactive status. So all these invalid, what I can say, invalid processes or resources, the lock process will identify and try to clear these inactive sessions or invalid operations. And mostly, what is the primary use case of this lock process? At the time of your restore and recovery, okay, at the time of your restore and recovery, especially on recovery purpose only, especially recovery of the blocks of data, the lock process will help to the services which are going to, by using the RMAN, we are going to recover the data, any specific data. In recovery process, the lock process will help to maintain the instance resource requests in consistent states. Not inconsistent, I can say, proper, make it a valid, or removing this from this block from the memory. If it is a possible, it is making to valid. If it is not a valid, it is going to remove it from this one. So recovery, at the time of recovery operations, the lock process will help to achieve that recovery activity. LMD will detect high level. I'm going to talk about this background process, guys. Lock process will help you as part of your recovery operations. Okay, all the nodes, not only single node. If any one of the node level recovery is required, instance is down, again it needs to be restarted. At that time, the lock process will help to achieve the recovery on this node level or instance level. LMD will detect the deadlocks and share these deadlocks with your GCS, and GCS will take care of those things. So LMD process, lock manager daemon, will take care of your deadlocks. LMON will monitor intercommunication or block transfer from one node to another node. Okay, that will help on that scenario. Interconnection of your lock system, or not the interconnect of this reconfiguration, reconfiguration of the cluster services and the reconfiguration of your locks, cluster and locks. Reconfiguration of your locks and reconfiguration of your cluster, LMON process will help. It will help to make your GCS is a consistency place. Okay, LMS will take care of all your data consistency or copy. Whatever the data is there in our data blocks here, the consistency data is maintained by LMS and process, lock manager service process. Okay, basically it is going to help your GCS in a memory level. Global cache service and cache fusion related cache fusion related. If somebody will ask you what is mean by the cache fusion, cache fusion is nothing but the data block is transferred. If instance is failure, N1 node 1 is failed, the data which is there into your STR memory, this data block, specific data block, is transferred to another instance node 2 under memory into your database buffer cache. The block is transferred from one node to another node. This activity is called as a cache fusion through internode connectivity. Like in a rack, we have whatever the nodes is there, all the nodes should be interlinked or interconnected. Passwordless connection will be there. How that we can achieve? As part of our installation, I'll tell you. Your private IP will help on this part. Private IPs to internode communication, and virtual IPs also will be there. If any node failures, the other node, it will inform to the node cluster. It will inform to the cluster level scenarios. Okay, one node is not available. Immediately, remaining background processes will help. Like this LMON background process will interfere, and it will, whatever the information or connections is there, it is going to transfer to another node. That's where up to 19C database, before 19C database, DML operations will not support. DML operations will not support as part of your cache fusion, or if any node is failed, insert or update, delete operations is there. No, those will not, they need to reinitiate it, that commands. If one of the instance, the user is connected to this instance and he's performed one update command, this update command, in between he's going to update that information, this instance got failed. Okay, earlier before 19C, what will happen? This user again need to initiate it. He may get some resources not available or some other issue. Again, he need to re-enter that update command. What will happen? Next time the user session is going to connect to active nodes. Then he can able to perform. But before 19C, if the user is trying to access the select query, while he is trying to access the select query to this node, if the node is failed in between the select query, read the data from the data files and then is giving back, in between the node is failed, this whatever the request he did, whatever the data is fetched, that data is going to transfer to another node. By using this instance, he can able to get that information. So select operations are happen before 19C without any interruption to users. We don't, the user no need to send one more request to get that information. But prior to 19C, that is happened. From the 19C onwards, you can enable the DML operations also. This operation we need to do separately to enable the DML operations at the time of node eviction or node failed. Node eviction is the another interview question. What is mean by the node eviction? We are having 3 nodes in a cluster all together accessing a single database. Okay, suddenly this network, some issues happen and this node is evicted or shut it down. What will happen? All these 3 nodes in a cluster, it's frequently voting in a voting disk. Voting disk will be there. Those we can store it in a locally or in a shared location. Each and every node in a cluster, those should ping each other. Hey, I am present, I am present. Where those present are, the things, heartbeats will happen into voting disks. Okay, voting disks. I'll tell you later on, guys, this one especially. So this node is been voted, I am here. This node is been voted, I am here. But this node is not voted because it's shut it down. The service is not running to communicate your voting disk to say hi. Okay, and then this voting disk is the inform that okay, I have all the nodes. So I have 3 nodes all presented. As of now, it is down. It is saying that hey, node 1, node 2 is failed. It will inform to this. So if any node data copy or block copy at that time of the scenario, the services will not able to look for node 2. They will forget it. Why? Because the voting disk informed to this node and this node, node 3 and node 1, this communication happened. Node 2 is not running. So you can handle the request. So they will forget about the node 2 and they will in between node 1 and node 2 data will be transferred if anything is required. Okay, any cache fusion happen. Oh, that is the scenario. So if this activity we call this a this thing node eviction. Node eviction will happen in network issues or any cluster resource or human interruptions. So many scenarios is there. Due to that, the node is evicted. Cluster services is trying to restart the services automatically, but even though it is trying to restart, the CRSD process is trying to restart it, CRSD. Even though the node is not came up, then only the node will be evicted from the cluster. Again, what we need to do, we need to restart the services. Once you start the services, it is immediately go ahead and then inform to voting disk, hey, I am present. Then voting disk will communicate with the node 1 and node 3, node 2 is present. So this node eviction, how we need to avoid, that I can tell you in later sessions. That is the node eviction scenario. Another scenario, cache fusion. The data blocks from the memory to internally one node to another node, transferring the data blocks from one node to another node, we can call it as a cache fusion. When we need to copy, when the cache fusion will happen. Cache fusion will happen due to the network issues or lack of the memory issues or the instances. As in this scenario also, node eviction scenario also, the cache fusion will happen. The node is down, whatever the information is there in our data blocks in between the transactions, that will transfer to another node, either this node or this node. Any one of that node it is going to take care. That activity called it as a cache fusion. Okay, and another important thing, background process or global process, that is nothing but diagnostics. This will help this diagnostics global process will help to diagnose all the cluster related information like log information. It will monitor the cluster and make log files. Health of your cluster, you can say health monitor. Complete all the services of your cluster. It will maintain your cluster health or monitor your cluster health. Monitor and maintain cluster health, monitor, maintain. If any one of the service is not running, if any one of the background process is not running, any one of the services in the cluster, those are not running, how we can identify? By using this diag process, global process, it will monitor the cluster health checks. If any recovery is required, by using this diag also internally it will try to recover the services. Okay, if any necessary recovery is required, it will perform that. If any hanged sessions are detected, it will try to release that hanging process and other things. So it won't do it, but it will trigger to another services. See here, it will trigger to LMS process internally. So if any deadlocks occurred, LMD will identify and it will trigger to another background process. Internally, those will communicate to each other. But the purpose of this DAG is to monitor your cluster health and maintain the cluster health. All the information related to diagnostics of your cluster services, it is going to maintain with your DIAG. And those are all about our global process and our background process, you can say, and daemons. So now I can show you the cluster level daemons, which I have connected to the grid. CRS, CTL, stat, RES, resource-t-init. See, these are all our resources. See here, cluster resources. This is my cluster resource. Interconnect. This is the 11G feature, guys. High availability IP. What will happen? I'll explain you one by one. And CRF. This is also one kind of cluster resource. All these resources maintained by your CRSD, cluster resource daemon. This is the daemon where, and the status is the stable status. When you have initiated the cluster startup, all these daemons will start, okay? Remaining all these event daemon, drivers, diskmon, CTSSD, CSSD, all these daemons will start. Even though the priority, the 4th level, it is there, but it is not going to make it a stable, okay? It will start after all these resources has been started up, okay? I'll quickly explain these daemons one by one. This Vara ASM will take care of all the ASM instance level. If it is not came up, means your ASM instance is not started in your cluster level. So make sure this process cluster resource should be up and running. This is runs on our RACS node 2. I have connected to RACS node 2. I am seeing RACS node 2. From node 1 also we need to see the Vara ASM services should be the daemon process. This process will take care of your Oracle ASM level instances. And this cluster interconnect, node 1 and node 2, if they want to connect internally, Oracle 11G has been introduced this feature, interconnect HA IP address. What will happen? We have given to interconnect, what I said, we need to give the private IP. Private IP will take care of your node interconnection between the node 1 and node 2. Okay, who will take care? Private IP. We have given one physical IP, okay, physical IP, private IP, but internally, at the time of installation, grid installation, Oracle, the cluster software has been assigned one dynamic IP, Instead of this IP, by reading this internally, the physical IP itself, it will work to communicate internally, but Oracle has been introduced this high availability IP address. This we can see it also in netstat-IAN command. We can see this interconnection. So this is newly added in 11G future. This will help for internal network communication, but originally the private IP is going to work. Logically, this will help for internal node communication purpose. And CRF, this is one of the cluster thing. I'll tell you later on. And this thing I'll talk later. CRSD, cluster ready service daemon. It will I'll talk later once this is done. Okay. Cluster synchronization services. It will maintain the node eviction kind of scenario. CSSD will take care of this. This is monitor 24/7. This process, if the process is not running, your cluster is not in synchronization mode. Obviously, the CRSD will not start. So these two processes will not start up. That's where we need to check this, why it is not going to start. What will happen? The node issue in node 2 or node 1. Cluster synchronization service will take care of your node communication in a cluster. This is also another monitor daemon to help with the CSSD. I'll give you one thing here. For all the services, I have noted down here. Okay. CRSD, as I said, cluster ready services, it is going to make, it will make entire cluster resource online are there. Okay. This will start or come online last. Once all these resources come online, CTSSD, CMON, CSSD mon, everything should come up, then only this will come up. And CSSD will synchronization monitor purpose. CSSD keep monitoring and communication between your node 1 and node 2. Network heartbeat. Network heartbeat will take care of this thing, right? Voting disks. Voting disks. Voting disks will help to vote. Each and every node in a cluster should vote into voting disk. Like heartbeat will monitor in voting disk. If any one of those node is not voting in this voting disk, other nodes thinks the node is dead. That activity called as a node eviction. Okay, that could be a network issue or a disk issue. The to failure or node eviction related reasons. Okay, that node eviction, CSSD will take care of this node eviction scenarios. It will monitor these things and voting disks. That is the process of these two are the same. Okay, this internally cluster synchronization daemon monitor will help to your cluster synchronization service. Okay, and then next one is CTSS. This is a time synchronization daemon. In cluster level, if I can say date, what is the time in 8:29? The same should happen if I try to work from my node 1. This is also node 2, right? Let me try to use my node 1. This is my node 1. Date command to check your time on your nodes. So this is my node 1, RACS1 node. Time is 8:29. Let me check one more time. 8:29:40. Here, what is the time now? Same, right? 8:29:44. So who will take care of this time synchronization in between the cluster node? If you are maintaining 10 node cluster, who will take care of this? This daemon will take care of this. Okay, if the status of this one is observed, it is going to keep on observe all the nodes in a cluster. What is that mean? Whether it is shrinking the time zone or not. This should be there. It should be stable. Okay, this is the status. Diskman is another process where we can use this diskman for exadata servers, storage servers. See, if we are using RAC architecture here on premise. Okay, exadata is in a cloud servers. Even on premise also, I think we should maintain, but I never saw those things. But in exadata, if you are using RAC infrastructure on exadata servers, at that time this diskman will come into the picture. Until that's where we are not using exadata, the status of this diskman is offline. Apart from this process or resource, rest of the resources should online only. If one of the resources is not coming into the online, there is an issue in your cluster. In this way, you can say cluster is up and running and it is working fine. Okay, this is for ACFS, ASM cluster file system. If you are using ASM cluster file system in your rack, this drivers.acfs service will help. If this is not running, your file system is not accessible. And here ASM is the right. If it is not running, your ASM instance itself, it is not up and running. So this will take care of your ASM instance and this will take care of your ASM storage. This will take care of your ASM storage. This is also related to the storage. So disks are not mounted properly. ASM disks are not able to readable format. After server reboot, after OS patching, we saw this kind of issues. First of all, we need to monitor this ASM process, resource, and drivers of ACFS thing and the storage. These three should be come up. to access your ASM storage, to access your ASM instance. That is the important, guys. And then what else? Event manager. This is also one kind of, as I said, if anything happen, okay, this status is stable, this status is observable, this service is offline, all this information is going to monitor by this event manager daemon. This event manager daemon will monitor your services, and it is going to send a notifications using ONS services, Oracle notification service. That is also one process internally works with this EVMD. ONS services, Oracle notification service. Another thing is grid notification service. We have some ONS is there and GNS, grid naming service. This will help for your DNS. Okay, DNS is nothing but, so I am trying to call or trying to connect with this node with RACS2 with a host name. So as a human beings, we are going to remember the names only. We are not going to read the IP addresses, but system is reading the IP address format, internet protocol. System will read this into zeros and one format, right? Zeros and ones. So for system identification, we are using IP. For human identification, we are using RACs or host names. To host name and IP addresses together act as a single service. How that is going to act as a single service? By using this DNS. DNS will naming service, okay, domain naming services, directory naming services, we can say these service to help or identify the services in the cluster. Either it's a host name or IP address, those will communicate at each other internally. It will help. Okay, but in real time, we are maintaining this DNS in a separate servers. The storage team will take, network team will take care of this DNS services. But in our practical, in our lab, we need to configure this DNS server. Okay, dummy DNS server, I can say. But in real time, we should not touch these DNS services. Okay, DNS service is used for to identify the host names and IP addresses in a cluster services. So this event manager to enable the events, if any alerts has been occurred in our cluster service, that will take care of these things. This is messaging daemon. If anything is not running, if anything is fine, it is going to send a notification to applications or cluster. So if any abnormalities like it is not good, okay, in a cluster, it will send a messaging across all the cluster nodes. One node is evicted. Who will identify this? Event monitor is going to identify and it is going to send it. So event manager will take care of these abnormalities of this cluster and it is going to send a messaging. That is one thing. Okay, and one more thing I want to say, this drivers.acfs, right? For ASM disk groups, it is going to send, right? As and when we are going to add a disk or extra memory or extra storage to this disk group, especially this process will take care of the storage level. From ASM disk group size, we can local mount points. Two systems we are going to maintain, right? So local mount point is different and ASM cluster file system is different. Local mount point is this one, df-kh. If I can say this is my local. If I want to store my data files in locally, I can do. If I want to store my data files into RAC, not ASM file system, ASM cluster file system, that file system will store data plus symbol. It will store in this kind of directories. This we call it as a disk group. So data will store it into disk groups, that we call it as in ACA file system. If the data is stored into U01 or U02 or temp or app or data, this kind of mount points, those are in local file system. Those files are local file system. If the data stores in your plus symbol sign and data or reco or archive or any other names, that is your ACM file system. ASM file system. ASM means automatic storage management cluster file system. That is the difference how we are going to identify. Those will monitor by this daemon. This will monitor that. And these two are the profiles. GPNP. Node addition and deletion. If you want, I have two nodes as of now. This one, RACS2 is one node. RACS1 is one node. Those two are in a grid cluster and those two together act as a single machine and we are accessing our database. If you want to add RACS3 node, this will help and grid plug and play. This is the daemon name is grid plug and play daemon. This will help for node eviction, node additions, deletions. At that time, this will help. Where it is. Grid naming services, that is a GNS related thing. Where grid play, this one, grid plug and play daemon with help this profile. That is a profile where it is going to store grid home, GPNP hostname profiles, this XML file. GPNP is the XML file. It is profile. The profile is stored in the format of XML file in a ASM disk groups. There, and also it is maintaining all the informations where exactly your storage is stored, where exactly your SP files. This will help to maintain this profile in a grid level. Okay, what are all the information inside of GPNP? I'll show you that as well. Another one is GPID. This is the grid interface or inter-process communication daemon. So this is, we are not, if you want to use this daemon, this process is as of now up and running, right? As part of the grid installation, it is going to handle the scan load balancer. Who will take care of that load balancer? Okay, scan IPs locally to identify the scan IPs, to fix or to identify the node, internode communication, which node is having less node, which node is having less data. The scan will assign the load to that node. How the scan knows that? This process will take care of that internal or inter-process communication or internal node communication process. This daemon will help to. If the daemon is not running, if the daemon is down, the internal communication between the racks nodes into the cluster will not happen. This is a profile, as I said, in grid home. Even though I mentioned Oracle home, it is going to grid home only. We set up. How we can find out that? We can see env pipe grep ora. So this is my ASM instance too, and this is my grid base where my diagnostics and other things will store, log files and other things into your base location. And this is my grid home where my grid or cluster binaries has been installed. Okay, presently where I am, the same, right? U02 grid home location only I was there. GPNP, right? Inside of your Oracle home, you have profile directory GPNP. For this GPNP, we are going to maintain profiles. These are all the profiles. If you want to connect to this specific profile, you want to see profiles and peer. This is my profile, guys. This is my profile. This profile is going to read it at the time of your node startups or shutdowns, or to maintain your node. This GPNP is a very, very important profile in your cluster. What are all the information? This profile is holding XML format, right? It stores in XML format. This is having all the information. So URLs is there, some of the ASM profile ID. What is your ASM ID? ASM. And where is your disks in ASM? In this location, dev Oracle ASM. Do I have those disks or not? Check it, see. OCR data archive. These are my disk groups which are there in my cluster. Those location also I have given. The disk location. Where is your SP file? To start your instance, you need SP file or any one of the parameter file. In RAC, we are using SP file, guys. You can forget about the P file. We are using SP file, server parameter file. That is also going to maintain where I have my SP file. You can see the file, we can read it from the ASM thing. Okay, connect to ASM CMD, ASM CMD -P LSDG, list of the disk groups. Where it is OCR location, I have my SP file. In this directory, I have. Go to that and racks. Inside of that, I have ASM folder, password file, backup file, cluster files. RAC cluster, inside of my RAC cluster, ASM parameter files I have. Here is my registry location. This is my SP file location where my parameter file is located. Okay. So everything, all the information is maintained by this profile. At the time of instance startup, the background, the processes will read this GPNP process, grid play and profiles, and it will start the information. Grid plug and play daemon will help this profile maintenance. In this location, we already see, right? Where is your SP files, all the node specific information. This node specific information will read it, and then that node will be started. Yeah, that's all about this session, guys. Do you have any queries? So that will conclude I'll share this information with you from here. All this information I'll share in a document. Okay. I'll post it. I'll upload in our Google Drive today. Okay. About this. And tomorrow we can see cluster installation phase. I will share this document, guys. All this information, I'll share it. Yeah. Do you have any queries? Okay. Thank you.